Welcome back to part 3 of Introduction to Fritzing. Today we will be using our Thonny IDE to write Python code that matches up with our Fritzing software. We're going to go into our programming software, open up Thonny here, and that should open up a window where we can start coding and using our Fritzing software to help us plan. So I'm going to open up a new document here. We're going to write a code that allows access to the LED lights that come with our Raspberry Pi kit. So we're going to start our code by importing the LED light from our GPIO0 library. Then we're going to use a time variable. So we're going to import time from the sleep library. This will not be in seconds. It will just be a variable of time. For example, if we use 1 or 2, it will not be 1 or 2 seconds. It will just be 1 or 2 predetermined variables of time. We're going to name our LED light. I'm going to name it My LED, and making sure that we keep our capital letters from our GPI0 library to make sure that we are using the correct identifier. We're going to use the number 5 that indicates our LED light is connected to GPIO pin number 5. We're going to write a conditional statement, our while true statement, to allow us to program what our LED light will do. We're going to turn our LED light on by typing my LED period on with empty brackets. We're going to use sleep, and we're just going to use 1. We're going to turn our LED light off, and then sleep for 1. This will turn the LED light on for 1 interval of time, and then turn it off. Before we run our code, we have to save it. We'll save it as LED test 2. We can run our code, and your light should turn on. This is a relatively simple project, but just kind of shows you how you can use your planner, your Fritzing software, to plan our coding. So we use the GPIO5 library. This will be more helpful when we're using numerous physical components. So when we're using our Fritzing software, we can import our red LED light. Make sure our cathode leg is on the ground side, and our anode leg will be plugged into our GPIO pin. In Fritzing, we can rotate and move around our parts. So I'm going to rotate it just so it looks a bit cleaner on the board. Make sure the pins are pinned into the correct sides. And now we can start pinning up to our T-cobbler. So we use GPIO5, and we're going to need a resistor to plug into a ground cable. So here's our resistor in our core parts bin. Again, we can move the leg similar to what we did for the LED light. You can see the green lights are lit up here, indicating that they're in the same line. Now we're going to run a a ground pin to a ground in our T-cobbler. See the yellow lit up there, indicating that it is available in that line. We're going to pin up to GPIO5, which we mentioned in our code. This is what your breadboard should look like when you start pinning. Now you can use your physical breadboard to pin something similar, and once you run your program, your light should turn on. We can edit our lights, rotate it more. We can raise them, copy them. If you wanted to, you could edit the actual component, but we won't get into that. We can change the color of our wires. Let's do a color that kind of indicates ground. We'll do green, and then we'll make this wire red to show that it's connected to our red LED light. There you have it. There's a pretty simple breadboard operation. We can create a bend point here once we're using more more components, this will be helpful. It kind of keeps track and makes it look a bit cleaner on the board. There you have it. That's a pretty simple Fritzing example. Now we're going to create a more advanced code so we can see what a bigger system looks like on our breadboard with more components. So we're going to make a stoplight, which will be just a more elevated version of what we did last. We're going to do the same thing and import our LED lights into our code. We're going to use 3 LED lights, a red, green, and amber or yellow. We're going to import time as well. That will be important for when our lights blink. We're going to have them kind of count down. We're going to name our lights according to color. So we have green. Let's put our LED in 4. Yellow will be in GPIO pin 22. And our red LED light will be connected to GPIO pin, let's say 5. We're going to make a while true statement as we did in the last. It will just have a longer script. So we're going to have the green go first. The same code, we're going to turn the green on. It will sleep for 1 interval, turn it off, sleep for 1 interval again. Then we're going to have our yellow or amber light blink next. This will be all under the same statement. So our yellow will turn on, sleep for 1 interval, turn off, sleep for 1 interval. Then our red will turn on. Sleep for 1 interval, turn off, and then sleep for 1 interval. Don't forget to save this when we're done. It needs to be saved in order to run. We'll save it as a stoplight test, and then we can pin our Fritzing software, which will help us plan our breadboard. Alright, let's get started with our more advanced stoplight program. So as you know, we're going to need resistors to attach our cathode pins to a ground cable. We need 3 LED lights. I'm just going to drag and drop the components onto our grid. We can change the color of our lights by going down here in the right-hand corner. So we're going to do green, yellow, and a red LED light. Once we have our components, we can start planning our breadboard. We're going to create this line here. We're going to create that as a ground connection. So from the side line, we're going to connect to just any pin and show that this is a ground connection. That makes that entire line of pins a ground. So we can just connect our resistors directly into that sidebar there, which makes it super helpful when you're doing something like this and you need a lot of space. You don't have to have 3 cords. We can just connect the resistors directly into our sidebar there. Perfect. So once those are sorted, we can rotate and place our LED lights on the breadboard. As we can see, this is starting to look super organized. We can clearly tell what resistor is to which light. The lights are evenly spaced apart, makes it super easy to keep track of. Perfect. So we can see that everything is lighting up green where it's connected. We'll change the ground wire to white to indicate that it's a ground wire. We can start pinning our lights to our GPO pins. So I believe we did green to 5. Change the wire color to keep track of which wire is connected to what pin and what light. So green for green. We'll bring that out there so we can make room for the other pins. Yellow was connected to GPIO 22. We'll change the wire color to yellow. Add a bend point to make it a bit easier to see. Then we'll connect our last and red light to our GPIO 5 and change the color to red to keep track of it. So once you have your physical board pinned, you should be able to run your program and your light should blink green, yellow, red, and then continue on the loop until it's ended. Thanks for joining. I hope you enjoyed this introduction to Fritzing.